Alright guys, so today we're solving systems of linear equations by graphing. So what we're eventually going to get to is something like this, where we look at this here. I drilled 16 holes in a piece of a broomstick handle. I want to fill the holes with $1, $5, and $10 bills. I want to give $50 and have twice as many 5s as 10s. How many of each denomination should I put on the tree? Well, so it's a Christmas money tree, obviously. And what you have with the system here is you have multiple conditions that you're trying to solve for or account for in the solution, which is why you end up with multiple equations, which is why it's called a system. So you have a system which is two or more equations with same variables. So as an example, you would see something like this. Y equals negative 6x plus 9, 2x minus 8y equals negative 32. So there are three different methods that you can use to solve for a system of linear equations. Today we're just going to focus on graphing. When you find the solution for a system, by the way, what you're looking for here is the two variables in the set of ordered pairs, x and y, that works. Basically, and what you're going to look for here when you're graphing is you're looking for the two lines are going to essentially intersect. And that point is going to be your solution, where the x-coordinate's your x answer, the y-coordinate's your y answer. So once again, with the linear systems here, there are three different scenarios. And a lot of these you'll recognize from geometry. So one scenario, you get this. Two lines cross, they intersect at a point, and you get a nice, solution. So that's what I said here. In this case, you get one solution. Lines are intersecting here. Whatever that coordinate is, that's going to be your x and y answer. Second option here, no solution. These two lines, what's that called again? Starts with a P, ends with L. Got parallel. And then lastly, you have an infinite number of solutions because the two lines are actually the same line. And what happens here is it's an infinite number of solutions because each of these little red points that I'm putting on there, each of those technically is an intersection of both lines. And so there's an infinite number of points that you could pick, hence an infinite number of solutions. So like I said, here's what we're doing. We're solving a system by graphing. First, you want to graph the first line, graph the second line, find the point or points of intersection, or if they even intersect. So let's graph this first. So right now, pause the video, try graphing on your own, and let's see what you come up with. So once you've drawn these lines, as you see here, what you'll notice is that they intersect at that point right there. So where they intersect, that's your answer. So your answer here, we're 2 in the x direction, and we are 1, 2, 3, 4, negative 4 in the y direction. So you would say the solution of this system is that x would equal 2, y equals negative 4, 2 comma negative 4. So like I said, we have our points, do our line, now you try. So once again, go ahead, try graphing these lines, pause the video, and then when you unpause it, I'll have the answers up there so you can see how you did. So what you'll notice here, you can take a quick look. See how the lines are parallel, the slopes exactly mirror each other, which means there's going to be no solutions. As in order for there to be a solution, these lines have to touch or they have to intersect. In this case, if they never touch, hence the definition of parallel lines, there won't be any solutions. Alright, try this one on your own, and like I said, we'll pause the video, and then when you unpause it, I'll have the answers up there for you. Now this would be an example of an infinite solutions, because once again, you'll see here you have the purple line for the purple equation, green line for the green equation, and the lines literally lay on top of one another, the exact same equation. So this would be under an infinite solutions. So we'll write that in there. Okay, so now we gotta look at a word problem here. So first thing we're gonna have to do is set up the equations, then we're gonna graph them. So you have the sum of two numbers is 5. So that means we're going to have a number x plus a number y, and it's going to equal 5. Then it says the difference between the two numbers is 7. So difference means subtraction. So x minus y is going to give us 7. What are the two numbers? So now what you're going to do is you're going to graph both of these equations. So go ahead and graph them. Pause the video, and then when you restart it again, the answers will be up there for you. Alright, so as you can see here, we have our two lines graphed. And what you'll notice is they intersect at that point right there. So our answer is therefore x would equal, let's see, 1, 2, 3, 4, 5, 6. Okay, so x would equal 6. Y would equal -1. And if we think about it, let's just kind of see if that makes sense. So the sum of the two numbers is 5. So 6 plus -1 would be 5. Makes sense. The difference between the two is 7. 6 minus -1 would be 7. Makes sense. Alright, so then that's it for today. Here's the assignment. Like I said, you can take a second and pause it so that you can write it all down. And you can also pause so that we don't have to get the book and you can check your answers here. So here's the first page of problems. Here's the second page. Now make sure when you're doing these, ignore the directions and solve them all by graphing. So make sure, like I said, you're actually solving by graphing because that's what we're working on here today. If you need graph paper, I have some up here. Hope it makes sense. We'll briefly go all of this when I come back, or over all this when I come back tomorrow. Have a good one, guys.